Here's a couple of additional examples in the chain rule. And the first function here, f of theta is equal to 1/4 sine squared of 2 theta. Be very cautious here. Sine is the thing being squared. So it's really sine 2 theta times sine 2 theta. Then the next one we'll see we're squaring 2 theta. All right, so starting off with this, we are going to notice that we need the chain rule in order to take the derivative because we are told to find the derivative with respect to theta. Okay, well, when we do this, we need to really start looking at some interior functions. So let's take a look at a mysterious function g of x. And I'm going to say, okay, now suppose I'm going to ignore the 1/4 because the 1/4 we can actually bring out and it doesn't matter. And so concentrating on just the sine squared 2 theta, what is the last thing being done? And the last thing being done here that I can see is that we're taking some input and we're squaring it. Which means if we take the derivative of that, then according to the chain rule, I take the derivative of that, which is 2x, and then it's x prime. Okay, that means I have to take the derivative of what's inside. So now the question is, what is being squared? Well, let's look at h of x is equal to the thing being squared, which is sine. The sine function is being squared. In that case, then, the derivative of the sine function is cosine of x, but now times the derivative of what's inside, times x prime. Okay, so now we have, again, we still have this x prime thing. So now what is the inside of that? And so this is really 3 nested problems. And so if we look on what's on the inside of that, we notice it's 2 theta. Okay, so let's say j of theta is equal to 2 theta. What is the derivative of, or what is j prime of theta? It's 2. Okay, so now let's put all this stuff together. We have to take the derivative of the outer thing. So since I'm doing that, I'm taking 1/4 out. The derivative of the outer thing is 2 times that outer thing. That's what this looks like over here. This is the structure of it. So it's 2 sine of 2 theta times the derivative of the inside thing, which is sine x, or sine 2 theta. Okay, so there's the structure. The derivative of that is cosine 2 theta. Okay, times the derivative of what's inside. What's the derivative of what is inside is the derivative of 2 theta with respect to theta, which is just 2. So you'll notice now that we have, in fact, 1. That's 1 derivative. Here's 2 derivatives. There's a 3rd derivative. And so we really have 3 nested functions here. So the important thing is to identify the functions that are nested and follow each one of those in a very simple sequence. If you could break it up like that, that's the easy way to go. So in the final answer here, we've got f prime of theta is equal to 1/4 times 2 times 2. So that really, 2 times 2 is 4. Divided by 4 is 1. And so I really have sine of 2 theta cosine of 2 theta. And I can quite easily just leave my answer just like that. All right, now some people might say, "Oh, well, can't we take it further?" I seem to recognize that. Yeah, we can. If you take a look at this, this looks very, very similar. If you know your trig identities, the sine of let's call it 2u, or the double angle identity for sine, is equal to 2 sine u cosine u. All right, so now if you look, we have only 1 up here. And so if we, instead of doing that, let's divide by 2 on both sides so that we get 1/2 sine of 2u is equal to sine u cosine u. And now if we just let u equal 2 theta, then we can follow this, and that gives us 1/2 sine u is 2 theta, so this becomes 2 times 2 theta, which is for theta. Okay, and so we can rewrite this as f prime of theta is equal to sine of 2 theta cosine of 2 theta, which is rewritten as 1/2 the sine of 4 theta. Now the second part here is not really critical. If you can get to this point here, that's probably going to be good enough. However, these trig identities do come in soon, as in integration, when we go backwards of taking the derivative. And so it's going to be important to be able to kind of walk that line and notice these trends. At this point, my students, anyway, I'm looking for the noticing part. Do you notice it? Do you recognize it? Then we can go find it. All right, let's move on to our next example here. And for our next example here, we've kind of mixed up the sine and the square root function. The very first thing that I want to do here is I want to rewrite this using the power rule, and so I have to use exponents. So this is going to be x to the 1/2 power plus sine. And now here we're squaring 2 theta, not sine. So 2 theta times 2 theta is 4 theta squared. Okay, so I'm going to use that there. And that's going to kind of help me out when I go to take this derivative. And so I want y prime. All right. Well, the very first thing we notice is that with y prime, we have an x to the 1/2. And so if we take, let's take f of x is equal to x to the 1/2. Here, there's nothing hidden inside of x, really. I made a mistake. This is supposed to be an x. We are not mixing things yet. I apologize for that. Okay, so everything's x. Nothing's in thetas. I'm getting my angles mixed up here. All right, so we've got our f of x is x to the 1/2. And so if we take its derivative, f prime of x, then we bring the 1/2 down and we replace it with subtracting 1 from the exponent gives us a negative 1/2. So this is the same as 1 over 2 root x. All right, so we'll kind of hold that off to the side. Our next function, g of x, is equal to the sine of some stuff. And let's not call it g of x because that's going to screw up our thing. Let's call it theta. Let's call it theta. And so we have sine theta. Inside of that g, we have an h. Okay, so inside that g, we have this h of, let's say, well, it's just h of x, really. And so h of x is 4x squared. Okay, and now everything's in terms of x, and so this one is not. And we'll get back to that. Let's go to the h of x here and take that. The h prime of x. So we take the derivative. We bring down the 2. It's 4 times 2, which is 8x. And then we decrease the 2 by 1 to give us 8x to the first. Okay, going back to the g of theta. G of theta is sine theta. The derivative of sine with respect to theta is equal to cosine theta. However, theta is actually a function of x. And so we have to take that and multiply it by that derivative. This is the chain rule in action. Okay, right now that's the biggest part of the chain rule. So we have to take the derivative of sine, and then we have to take the derivative of what's inside. So since we're not dealing with thetas anymore, we're dealing with x's, then that means that theta is actually a function of x. And in fact, it's h. Okay, so let's put everything together. Y prime is going to equal to the derivative of x of root x. We found that out to be 1 over 2 root x. So this is going to be 1 over 2 root x plus. Remember, because derivatives add. And so now, the derivative of sine 2x quantity squared is equal to the derivative of the outer thing, that g prime of theta, which is cosine of that stuff. You'll notice that that stuff got replaced by theta. So it's just that stuff times that derivative of what's inside, which is our h prime, which is 8x. Okay, now that 8x gets applied to the cosine. It does not get applied to the other. And so we have in our final outcome here, we have y prime is equal to 1 over 2 root x plus 8x cosine of 4x squared. Okay, so this I'm really not noticing anything that we can do to change this here, and so I would call that the end, simply because there's just we could get a common denominator. I don't see any particular purpose in it. Plus, we've got a problem here with the inside the cosine. It's not really a power reduction. It's not really double angle, and so I'm just going to let it be.